as you probably gathered from the way she presented herself, she is a NASA Solar System ambassador. And besides that, she's a docent when the Keck is open to the public at the Keck headquarters, the two largest visible wavelength telescopes on planet Earth, which is headquarters in Waimea, Hawaii, the island of Hawaii, and personal friend and member of the West Hawaii Astronomy Club.
I don't know how much you guys know about the Lucy mission. My slides here are from Southwest Research Institute and NASA. And the Lucy mission is a 12-year mission, main belt asteroid, and seven Trojan asteroids, Jupiter Trojans. And they've never gone to see 8 of them in one trip. So what they're going to do is go out to through the main belt asteroid, stop at one main belt, or go by and study one main belt asteroid, and then go out to the Trojan asteroids, which are in the orbiter of Jupiter at the 2 Lagrange points. They're at Lagrange 4 and Lagrange 5, these stable orbits that are ahead of and behind Jupiter in its orbit around the sun. And it's named Lucy because of the human ancestor fossil found in Ethiopia in 1974 that was named Lucy. And just like that, Lucy tells us a lot about our history. These asteroids will tell us about the formation of the solar system, mainly the outer solar system. Lucy's data will help scientists answer questions like what rocky and icy materials make up the giant planets. How and where did these planets form? Did they move around in the early solar system? And how did the materials needed for life make it to Earth? There are 4 types of NASA missions, 4 classes. Simplex is the cheapest, easiest, and the one they spend the least amount of money on. It's, let's see, $50 million is the cap for that one. The next one is the Discovery. This is a Discovery mission. Samples of Discovery were Stardust, Genesis, Messenger, Deep Impact, Dawn, Kepler, Grail, and Insight. And this one has a $500 million cap through development. This is not including the launch and in the future, but for developing. And then there's New Frontiers. That one is up to 900 million. And then the flagship ones like Voyager, Viking, Galileo, Cassini, those have no limit. Those are directed by NASA. The other 3 are directed by PIs. This one being from Southwest Research Institute. So then I was going to explain Lagrange points. Hopefully everybody understands them. These are in 2-body orbits. There are stable areas where you can place something like between the sun and the Earth is the Lagrange 1 point. And it's where the gravity of the Earth is pulling in one direction and the sun in the other. So we have like the SOHO telescopes out at L1. And it's mostly stable. It still needs a little bit of tweaking, but for the most part, it's stable. L2 out on the other side is out away from the Earth. So you have the sun and the Earth pulling in one direction. The other direction, you have centrifugal force pulling it out. That's where we're going to be putting the James Webb Space Telescope. And then if you draw a line from the sun to Jupiter to the Trojan to L4, you have a perfect equilateral triangle with 60-degree angles. So that's where these are. And this is a very stable orbit. So L4 is ahead of Jupiter in its orbit. L5 is behind it. And then, you're missing a picture of the spacecraft. It has huge solar panels. The spacecraft itself is about the size of a sports car, but the solar panels are enormous. It's 50 feet across. And this thing is solar powered. So it's going to launch, the window opens on the 16th of October and at 5:34 in the morning Eastern time. And they are hoping to launch on the 16th, but if they're unable to, the window is 23 days long, and they'll have about a half an hour each morning in which they can launch. It's launching from United Launch Alliance Delta 5 from Cape Canaveral. And the Delta is, the United Launch Alliance, their bigger rocket is an Atlas, which they're discontinuing them, but Delta's smaller, and then they're building these enormous Falcon rockets. So the Delta is smaller because, remember, we said it didn't get as much money, so they don't get the big rocket. So in order to get all the way out there, it's going to need to circle the Earth twice and do 2 Earth flybys, getting a gravity assist from the Earth. So this thing will go twice around the Earth and then fling out towards Jupiter, towards the Jupiter Trojans. And on the way, it's going to stop at one asteroid in the main belt called asteroid Donald Johanson. Donald Johanson was the scientist that discovered the Lucy skeleton. He was the head of that crew. And that night, they played Lucy in the Sky with Diamonds and named her Lucy. So the patch for this mission is a diamond. And she has the name Lucy. They're going to study, they originally thought they were going to study 6 Trojan asteroids then, but it turns out that the first one, Euripides, has a moon, and they discovered that with the Hubble Space Telescope. So it's Euripides, and then let's see, what was that moon called? I've got a picture of it, Kita. And we just have a really lousy little picture from the Hubble Space Telescope and paintings of what they think it's going to look like. But it'll be awesome to get some images of these things. So Euripides is the biggest Trojan asteroid, survivor of a massive collision, a family of asteroids. And then the second one will be Polymele or Polymele. That is the smallest target. The third one will be a strangely shaped one called Lucius. The fourth one is Orus. Orus is the reddest, literally red in color. We've been doing spectroscopy on these things from Earth, and some are gray, some are red, and some are kind of in between. And they're interested in what makes these up, what they're going to be doing spectroscopy and figure out what is underneath this, the parts that are smashed, and so they can see into it and see the inside. So after it goes to these 4 in L4, is this working for you guys? I'm so sorry about the no pictures. You guys can all hear me?
Following along well.
Okay, you have to use your imaginations and picture all this stuff. So after it goes to those 4 in L4, it would take a lot of power for it to go all the way over to L5. The Trojans are really far. They're actually farther from Jupiter than Jupiter is from Earth. They're really far away. So what it's going to do is then come back down to Earth, go 2 times around the Earth, and then I think it's going to go 1 time around on that. The third flyby is once, and then it's going to slingshot over to L5 and study a pair of the final targets of near equal mass binaries, Patroclus and Menoetius. And this is something they're really interested in. And I've got a Hubble picture here. It's just a little blur. It's kind of like what we knew of Pluto, the pictures we had of Pluto before we went out there with New Horizons. So Lucy's going to bring some instruments, and these will sound familiar to you. The first one's called LORI, L apostrophe, and then Lori, Lorri. The L with the apostrophe means it's from Lucy, but Lori, and then there's Ralph. Lori and Ralph, if they sound familiar, it's because they were on New Horizons. These are identical to the instruments on New Horizons. So Lori and Ralph on New Horizons, and Lori and Ralph on this one on Lucy. And then there's LaTes, L''Tes. That was on Osiris Rex, which is on its way home now from Bennu, and Osiris Rex. So that one's called OTES. And then there's a high gain antenna, and that will keep in touch with the Night Sky Network. What is it? The big radio telescopes out of Goldstone and Madrid and all. I can't think what they're called. Oh well. Anyway, so oh, I thought I put it on here. Okay. Anyway, so yeah, they will be able to track them from all over Earth. We have three big groups of antennas, radio antennas, at Goldstone in California and in Madrid, and then in Australia, so that they can track it all the way, no matter which way we're turned. Lucy then will continue after. This is going to take 12 years. So kids that are in the 6th grade now could be working on this mission before it's over. And 8 asteroids, 12 years, 1 spacecraft. They're doing lots and lots of stuff online. You can go to Twitter and Facebook and Instagram, and it's Lucy Mission, at Lucy Mission. The websites are fantastic. There are 3 websites, well, 2 mainly, nasa.gov/Lucy, and I can put these into the, and I'll go into the chat while Chris is talking and stick these in there. But NASA has a Lucy website, and so does Southwest Research Institute. And then NASA, if you click on resources there, if you're teaching any kids, if you're doing any kind of outreach, they've made coloring books and videos and coloring pages and lesson plans, and there's so much stuff. It's a group of 3 people, and one's an animator, and he's just fantastic. And they were just locked up, I guess, during COVID, and had all this time to create all this amazing stuff. So they really did a good job on that outreach. Pictures I wish I could share. And they're also sending a time capsule with stuff from artists and poets and famous people and all. So, and then Chris is going to talk to you guys about how Chris has helped out with this mission doing occultation events. And I think that's it for me.
Chris Erickson, I've known for a very long time. I met him when he was a native Alaskan at the Northeast Astronomy Imaging Conference. And when I was up doing some of my rotation as a volunteer at the Mauna Kea Visitor Information Station, all my regular friends are going, wait till you meet this guy, Chris. And I'm looking at him, talking to him. You remind me of this guy. And he goes, yeah, from Alaska. Chris Erickson is an electrical engineer, an engineer extraordinaire, bar none, I would say, who owns his own company called Summit Kinetics, where he actually works on doing communications for remote observation and control of various telescopes that are on Mauna Loa for research purposes, many for the University of Hawaii, and also a member of the West Hawaii Astronomy Club and personal friend. Thank you both for taking the time out of your lives to come out here to Connecticut to share with us. And my apologies for not doing that in advance. Chris, before we go through, Maureen, did you just say that twice around Earth, when we're going to L4, visit all of them except for the binary, come back to Earth and go back to L5? That is just wild.
Yep. Oh, and what I didn't mention, and I meant to say, is after that, when this is all over at the end of the 12 years, this thing's just going to keep doing this. It's just going to go in this loop. It's going to go out to L4, back around the Earth, back to L5, back to L4. And it could be going for 1 million years. They said they don't know how long it will last, but it's just going to keep on going. It's like on cruise control.
Now, Maureen and Chris, do you want to hold questions until after Chris's presentation, or take them at Maureen's and take them at yours?
Fine with the end, whatever you want to do.
I'd say take questions now for Maureen so that you can take questions somebody afterwards.
Everyone is on mute right now, but if anyone have a question for Maureen before we continue on? Just raise your hand or unmute yourself, or
What's the launch date?
The
16.
launch, yeah, the launch date is October 16th, which is
Oh,
also
okay.
Observe the Moon Night. That's International Observe the Moon
Hmm.
Night. So this will be in the morning and observe the moon at night.
And,
They have
wh- and
30-minute window for up to 23 days after the 16th, if they can't do it on the 16th.
okay.
Yes.
And where's it launching from?
Cape
Cape
Canaveral, at the
Canaveral.
Is it-
UCLA.
Okay.
I made
Okay.
notes and paid attention.
Okay.
Okay.
All right. Huh.
Anybody else? And I won't answer. I promised.
Well, when these come back to Earth and enter for gravity assist, I imagine they're coming out of space and they get in the groove and then they engage and do a revolution and then shoot out. It must have energy. It must take energy to like get in the groove and then get out. That I know it accumulates energy somehow from a gravity assist, but how can it keep repeat? Enter and exit. Like it must take energy to shoot off that tangent path to come
Yeah,
out of.
I actually went to had an updated meeting on it yesterday. And let me see what I wrote here. They said this is the first one that is completely solar powered, that it's using just solar power for all the maneuvers. I don't think it has any thrusters or anything to control it.
Okay, interesting.
Yeah.
Well, gravity assist is one of the things that gives it the momentum to get away and go further, as we've done for Venus and missions to even missions around to the sun. We've done shoot around other planets to get there.
The gravity assist works because the spacecraft catches up to the planetary body, Earth in this case, as that planet is moving in its orbit. So it's catching up from behind, and the Earth's gravity pulls it in, and that actually creates more momentum than it loses when it leaves the Earth's gravitational field. And thus, there's a vector positive addition to its orbit, and that increases its velocity and enlarges the ellipse of its orbit.
Yeah.
Like he said. Any last questions? Let me just do a screen check to make sure there's no hands up. All right, Maureen, thank you so much. I know it didn't go as planned, but I followed along, made notes, and was right there with you as if I heard it new, and it really was. Chris, take it away, my friend. Thank you for being here.
Well, glad to be here. I actually add one thing to the conversation about gravity assist, and I think that something that's important for all amateur astronomers to really understand and be able to share with the public properly. And that is that energy, of course, can be converted but cannot be created or destroyed. So as far as gravity, be able to convert some of that gravitational force to inertia is something that is well understood by scientists. But also there's another force that NASA uses quite a bit that actually is fairly misunderstood by most people, including most amateur and professional astronomers, and that is ram pressure. A lot of people think that meteors burn up in the Earth's atmosphere by friction, but of course you cannot have friction with a gas. And so what that process actually is ram pressure. And what NASA does is they, when these spacecraft return to Earth, that they'll take that tremendous kinetic energy that they want to shed. They want to get rid of that because they don't want to come back to Earth with those same kinds of inertias that they've been traveling around the Earth with. And the way they do that is by heating the atmosphere hard, rapidly pressurizing the gas in front of the spacecraft, which then takes a lot of that kinetic energy and converts it to heat, where it is then shedded, and the spacecraft lowers in speed to a point where it's finally able to safely deploy parachutes or whatever to land on a planetary surface like the Earth. And so once again, it's an energy conversion. And so meteors do not burn up by friction, they burn up by ram pressure. or the rapid pressurization of the gas in front of the object, PV equals nRT. That kinetic energy is converted to heat, which in turn heats the object. And so the object heats and superheats as it comes into the atmosphere and loses its inertia. And we can see it burning up there. But once again, it's ram pressure. It is not friction. So for all of you guys that have ever had a debate with anybody or assumed your entire life that friction burned up meteors, now you know that it does not. It is ram pressure. PV equals nRT. Anyway, let me see if I can share my screen here. And let's see if I can find the right one.
E equals MC what? RT?
Yeah, PV equals MRT, nRT, that's the natural gas laws. Okay, can you guys see my screen?
Yes, we can.
Okay,
Yeah.
excellent. Well, blunders never cease. Okay, my talk, I basically originally designed this talk to follow Maureen's more technical talk. I tried to think of something I could do that'd be sort of fun and entertaining relating to the Lucy spacecraft mission. One thing that John didn't mention that I'll go ahead and add now is actually I've been on the backside of the screen a little bit with the Lucy mission. Rather than being in the audience and seeing the front of the screen, being on the backside, involved in a little bit of the nuts and bolts. Not so much, or not at all in the design of the spacecraft or the original science mission and so forth, but I have been involved in occultations for NASA, for the Lucy spacecraft mission. I was also involved in occultation expeditions for the New Horizons mission. And what a occultation expedition is, it's basically, it's sort of like an eclipse. We have a distant solar system object that's going to pass in front of a distant star, and it's going to cast a very, very faint star shadow across the surface of the Earth. And if we put a picket line of telescopes perpendicular across the path of that shadow as it passes over the Earth, and then we have a bunch of high quantum efficiency video cameras with precise GPS timing and so forth, and when you can precisely time when each one of those telescopes detects the object occulting that distant star, and when the star comes back again, we can actually build a profile of this object and learn a lot about it. We can detect atmospheres, we can do spectral analysis of the atmospheres, we can detect moons, we can detect rings, we can detect other debris fields around an object, was important for spacecraft. Probably the most important thing we can do is we can detect the albedo of an object. For example, Hubble is able to detect the object itself, but it can't tell us if it's a small, highly reflective object or a fairly large, poorly reflective object. And so the albedo is the reflectivity of the object. And this is important, number one, so we don't hit the object, we get too close to it. And number two, it's important as far as proper instrument settings, so we don't over or underexpose when we take pictures or a spectrum or whatever else of this object. I'm sorry, say it again. I had an echo there, I think. Okay, I guess that was me echoing on somebody's machine. Anyway, so occultations are a very important science that helps us to study these objects like these asteroids surrounding Jupiter. It also allowed us to do quite a bit of study of MU-69 before the New Horizons spacecraft got there. NASA sent me to Argentina twice and other places around the world. I've been to Australia, New Zealand, and other places doing occultations. We've even done some of them from right here in my own driveway. We did an occultation of Pluto. In fact, the 4 moons of Pluto and other details of Pluto, a lot of that we discovered from occultations before the spacecraft got there. We can also determine things about these objects that even the Hubble cannot see. And so occultations are pretty important, and that's where my primary contribution to the Lucy mission has been, as in occultations, and then into the New Horizons missions before that. But so I wanted to talk about occultations a little bit, but I also wanted to talk a little bit about some other things. Being involved with SWRI and NASA behind the scenes, you get to learn a few things, you get to know some people, and you get to see some of the sausage making that goes on with missions like this. And one of the things that, let's see if there we go. you guys can see my timeline here of the Lucy mission. And you can see that about 3 million years ago that Lucy walked the Earth. 1943, future paleoanthropologist Donald Johanson is born. He's the guy, of course, that discovered the Lucy fossils. 1959, future planetary scientist Harold Levison was born. 1963, future astronaut Lisa Caputo Nowak is born. And you'll find out why she's involved in all of this. 1965, future astronaut William Oliphant is born. He's also involved in this indirectly. And 1965 was also an important milestone because that's when Star Trek was first given the green light to go into production by Desilu Productions, who was owned by Lucille Ball and Ricardo. I don't think his name was Ball. What was his? Ricardo Arnaz, I think it is. And it was very critical, and Lucy made those decisions. So we have Star Trek because of Lucille Ball. And she didn't understand Star Trek at all, but she thought it was significant. It looked important. It looked a little bit like Cowboys in Space. And so she went ahead and approved that project. So we have Lucy Carmichael and Lucille Ball to thank for Star Trek. Julian Lennon draws a picture of Lucy in the Sky with Diamonds in 1966. This is also an important milestone in the naming of this mission. The Beatles recorded Lucy in the Sky with Diamonds in 1967. And they also had a little bit of controversy, of course, with the name of that song and the song itself. There are those people who believed it was a celebration of drugs and narcotics somehow. Some of those accusations were a little bit far-fetched. I think this is one of them. In 2006, astronaut Lisa Nowak becomes infamous. You guys, you remember that, right? The diapered astronaut. Oh, but I also skipped one. Let's see, 1974, Johansen discovers Lucy in Ethiopia. That's an important one that plays into this. And yes, they did play Lucy in the Sky with Diamonds quite a bit there at the camp. And that sort of played into the name that they gave to the fossil that they found. In 2008, there were discussions about the missions to the Trojan asteroids at SWRI and NASA. And one of the important things to know about NASA projects, it's almost a little bit like when they make a movie. You ever see a movie and you see someone labeled as their producer? Okay, what is a producer? The producer is like the principal scientist on a mission like this. There has to be somebody who really believes in it and champions it and goes out there and tries to develop support for this mission and for this expedition against all odds and against resistance from all directions, and trying to get the buy-in from who are effectively their competitors within science. Other people will support their project who also got their own projects they'd like to find support for. So it's actually quite of a challenging position to be in as far as the principal investigator, to get people to buy into and believe in your project and actually being willing to support it as far as within the halls of NASA or other places in the halls of Congress, and try to bring it to a reality. 2019, actually, so 2017 was when the Lucy mission actually got a green light from NASA. And this was quite a time of celebration within SWRI, the Southwest Regional Institute, and NASA. And especially amongst the people who are the primary promoters of this, who spent a lot of time and a lot of work trying to convince all the players and powers that be that this would be a really valuable mission that should be supported, that it could give us some good science and will advance human knowledge in a very fundamental way as far as some of the origins of stuff in the solar system. How did the solar system form? How did it get here? How did it get here in its current shape? What were some of the primordial building blocks of the solar system? Well, we think an awful lot of this is out in the outer solar system where it's nice and cold, whether it's the Trojan asteroids around Jupiter, or it's out in the Kuiper belt or in the Oort cloud and so forth. These are some of the primordial components of our solar system that come up and make who we are today. And so they were able to convince the powers that be that this would be a great mission that would give us some of that knowledge that would improve or increase our knowledge about the foundation of our solar system and how it works. Now, 2019, the movie Lucy in the Sky was released. This is not a good thing. We'll get into that a little bit later. This causes also in 2019, everybody removes all the unofficial Lucy paraphernalia from the NASA and SWORI offices. And we'll go into that. And NASA scrubs all alternate Lucy references from their website. Then we'll go into the rest of the timeline here in a second. About 1 million years from now, there's a good chance that the Lucy spacecraft could actually impact with the sun, and that will actually finally end the Lucy mission. Here are the bones. You guys have probably seen this picture before of the Australopithecus Lucy. In 2015, when they finally got the green light, that's when we got this great little logo here they put together for the mission. Here's a picture of Hal Levinson. Dr. Levinson is the principal investigator. He was the guy behind the scenes who pushed hard for the Lucy mission and pushed hard to get an awful lot of people excited about it, willing to support it, willing to promote it, and to go out there and do the campaign amongst all the various players within NASA and within Congress to support this particular mission. Here's some pictures of the Lucy spacecraft. You can see that we have technicians and engineers laying on platforms up here working on putting things together. They are not actually connected at all to the satellite. They're hovering near the satellite so they can work on it without putting any pressure on the satellite. This is also a large clean room. And I presume that those are all those platforms are nicely bolted together, unlike that one satellite incident we had a number of years before that, when somebody borrowed somebody else's bolts to the platform, ended up with a satellite dumped on the floor. And here you can see the size of the solar panels working on the spacecraft. Now, one of the things that goes with promoting a project like this is behind the scenes, there'll be an awful lot of, like I said, people are trying hard to be enthusiastic, convince people this is a great mission, and do a lot of promotion. Part of promotion is there you'll find a lot of things that there'll be cookies or food products. You'll have things like coffee flasks and things like this. There'll be a lot of stuff, a lot of stickers as they go around trying to promote their mission to the powers that be. And also there's quite a bit of fun in public outreach, and they try to do all kinds of silly and fun things to promote the Lucy mission. Now that, once again, here's our hero, the person who is responsible for giving us Star Trek. And indirectly, we probably owe her a debt of gratitude for an awful lot of our modern expeditions and efforts, because she had the vision to support Star Trek, which created an awful lot of positive public opinion for astronomy in general. In fact, you can see a lot of people have given her credit, like here they got her in a Star Trek uniform. Here they have her as a captain of a ship. A lot of these pictures were in and around NASA and SWORI, the Lucille Ball. There was also quite a bit of things like etch-a-sketch pictures like this, a lot of mugs and a lot of cookies, and a lot of things that were also Lucy in the Sky with Diamonds. Of course, this was controversial because LSD was in the name, and there was some ultra-conservative groups that felt that this was somehow promoting drugs. And so there was a minor controversy back there about that. But Lucy in the Sky with Diamonds is also being played around SWORI and NASA. And there was album covers that were framed like this that were up and around. And also there's a industrial project management software product called Lucy. And that was also brought on board and used extensively in various parts of SWORI in support of the mission. And so you had everything you could find. In fact, it was sort of fun. It was sort of the thing to do, to find everything you could related to Lucy and bring it into the office and frame it and have it on your desk or have it on your wall, and sort of a Lucy mania. And they had a lot of fun with that. But then something bad happened. Everybody remembers the story of the diapered astronaut, Lisa Nowak, and how she tried to attack and kidnap and possibly maybe even kill her romantic rival. And this became a big NASA story, not a NASA story, but sort of a NASA story. And then unfortunately, Hollywood came out with a movie called Lucy in the Sky, starring Natalie Portman as Lucy Cola, based loosely on the Lisa Nowak story. When they named this Lucy in the Sky, suddenly there was major panic that rippled through various halls of science, and the order came down that all references to anything other than Lucy the Astromedicus would be immediately removed and scrubbed from everywhere and everything in the mission. They wanted nothing that would even remotely connect their mission to Lisa Nowak and the unfortunate story of the diapered astronaut. And so all of the pictures of Lucille Ball all vanished, all the cookies, all of the coffee mugs, all of the everything that was sort of silly and sort of semi-Lucy related, just for fun, just for promotion, all of it had to immediately vanish from the halls of NASA in Surrey. And by the way, this is a really bad movie. I wouldn't recommend see it. It's really boring, and you'd probably get more science out of Star Wars than you would out of this movie, and that's really saying something. So that was unfortunate, and so that's sort of some of the stuff that happens on the backside of some of these missions, because there has to be an awful lot of outreach, and part of outreach to persuade people to support missions like this is a lot of paraphernalia, a lot of silliness, a lot of fun stuff. Well, all of the fun stuff had to be scrubbed. So just a little bit of a background. Now, occultations, this is my thing. Now, there's going to be an occultation in Spain, 1st of next month. In fact, I'm leaving in about a week or so, a week and a half, to go to Spain to be part of this occultation for NASA/Surrey in the northern Spain. And I'll probably be involved in a fair number of other occultations. Right now, there's probably about 50 hardcore occultationists around the world. Most of them are in the US, but there's also a fair number in Europe. And when NASA is looking to find more information out about things like MU-69 or these various asteroids, that they turn to the occultationists, and they will pay us to travel somewhere in the world, all on their expense, to capture one of these stellar shadows as it passes over the Earth, so they can look at the shadow and learn more about these objects as far as to fine-tune the orbital parameters of the probes, make sure the probes don't hit any debris, hit any rings, hit any moons. And also, most important, as far as they're concerned, is be able to set the cameras and instruments correctly for proper exposures, because they're going to be moving past at a pretty high speed, and they don't want to hit anything or miss anything, because they're not going to get a second time around with these objects. Now, an occultation, here's an example of an occultation. This is a real occultation that happened on a previous asteroid, where basically you can see we have about 1, 2, 3, 4, 5, 6, 7, there's 8 telescopes here that were set up in a picket fence across the path of this particular shadow. And we captured the object. We also captured evidence of a moon on this object. You can see from this particular occultation. Things like, even the Hubble doesn't have the resolving power to determine precise shape or to detect these moons and so forth. So occultations are critical for being able to do this. The other thing that an occultation can do, of course, is we can nail down the orbital parameters of an object much more finely, much more quickly than you could, say, with periods of observations over time from any other observatory. And the shape of the shadow on Earth will be exactly the shape of the object in space, because the distance of the star behind it, that the parallax area will be just about 0. And so if this shadow right here were, say, 7-8 kilometers across, that'll be just about precisely the actual size of the object, 70 kilometers across. Here's another example of another occultation. And we do a little bit of a datal normalization. You can see we got some of these outliers, and taking this and prior observations to do a predicted shape of the object. This is an example where it turns out one object is actually 2. You can see we had about 30 different telescopes set up in the picket fence across the path of the shadow of this particular occultation. It turns out we caught an occultation of the shadow of 2 objects. So these are the great things that occultations can tell us. And here we're just doing reverse rather than showing the lines, and we're just showing where the data was in the middle here, and be able to detect the shape of an object. Typically, we end up with maps like this that shows the path of the shadow across the surface of the Earth. And this is actually a MU-69 occultation, took place a few years ago. I was in southern Argentina, by Patagonia, and just passed over. And we had another crew over in South Africa down there to capture that one as well. And this particular expedition, both teams completely missed the occultation. It turns out the calculations weren't precise enough, and we were about 3 kilometers too far north of the actual path of the occultation. So yeah, deploying all these teams to southern Argentina and then to South Africa, and we missed the occultation. And so it does happen. This is the occultation coming up in a few weeks, October 1st. We have an occultation crossing over northern Spain right here. And Oviedo, I think that's how you pronounce it. That's where we'll be based at for this particular occultation. We'll be deploying from there. We'll do a number of practice nights to make sure we can find a good spot to set up that's nice and dark with our telescopes. We're going to be using 16-inch go-to Dobsonian Star Masters, or not Star Masters, but Orion Star something. And then we'll be using a special occultation camera. It's about $1,000 camera. It's made by QHY. It's the QHY 174M-GPS. And this is an actual, it's not a CCD, it's a CMOS camera, but it has a GPS built into the camera itself. And it's capable of up to 450 frames a second, but only with really bright objects. For everything else, we're going to be running about 1/4 second frames. And each frame will have a precise GPS stamp of the precise time to the millisecond when that exposure was started. It also gives the precise latitude, longitude, and altitude of the observer. And this helps us to create those occultation maps to determine the size of the object. This is the actual star field we're going to be using for that occultation. That center star there with a little purple hairline cross marks on it, that's a star we'll be looking for. Now, when you're looking into the stars, one of the biggest challenges of occultations is getting on the right star field. You can see in this picture that we have a number of bright stars, a little bit of a bright box around that star. That will help, but quite often what I do is I look for little lines of stars. You can see a little arc of stars just above and to the left. I don't know if you guys can see my mouse or not. There's a little line of stars just above and to the left, and looking for that unique pattern in the sky to make sure we found the right spot to do the occultation, make sure we don't get on the wrong part of the sky is pretty important. There's also a little bit of an asterism pattern a little farther over to the left, and there's some asterism patterns to the bottom right and so forth. So these are things we look for to make sure we're on the right field, because these telescopes, these Dobsonians, we need the 16-inch mirror for the light gathering power. But of course, the go-to system on those scopes isn't all that great. And so we want to make sure we hit the right star field with our cameras. And having these pictures in advance will help us to do that. The other challenge is what we get for a screen usually looks like this. And so we're trying to look at a live screen. It looks a lot like this and compare that to this to try to find or make sure we're on the right part of the sky, that we're on the right star. And we're going to be able to capture the occultation and not be looking at the wrong spot. You can be, just a couple of arc minutes off and completely miss the occultation. So this is probably the biggest challenge, is finding the star field. Also, different telescopes might reverse left and right. They might reverse up and down, and they might rotate the image. And having the correct image is really important. One thing I found is, personally, I'm dyslexic. I flip things left and right and up and down, back and forth very easily. It turns out, for some bizarre reason, that's an advantage when it comes to finding the star field and occultations. I can spot backwards and forwards patterns and compare them more easily than it turns out than many of the people I'm with. So this has probably made me a little bit more valuable of an occultationist, is my dyslexia of all things. Now, this is an example of the photometry of a target star. Now, because of the atmosphere, that star is bouncing all over the place. And you can see that. If we were out in space and using the Hubble, that this star would be a straight line across there, except for that notch when the distant star is being blocked by that asteroid or solar system object. And so this is the exact kind of graph that we get. It's not very exciting as far as graphs go, but occultations get pretty excited when they get something like this. It really, we jump up and down, we make all kinds of funny noises. It's just the same thing as if you just spotted land and you've been at sea for 6 months. This is what gets us excited. It's seeing that notch. Here's another actual occultation. You can see that this is of MU69. And you can see from that, the shadow there, it looks like it's shaped more like a peanut than anything else. Well, further occultations and zooming in, we can see patterns like this. And here's a photo of the actual object when MU69 was imaged by the New Horizons spacecraft mission. So compare this to that and that. Gives you an idea of what we're trying to do with occultations to collect this data before the spacecraft gets there and gets these kind of pictures for us. And so we determine precise orbital calculations. We can determine the size and shape. We can determine the albedo. We can discover atmospheres, the density of atmospheres, and composition of the atmospheres. Basically, the notch will have sloped sides if there's an atmosphere, and the change in the starlight when the starlight's being viewed through the thin amount of atmosphere near the side of the object, the change in the spectral analysis of that starlight tells us what's in the atmosphere of that object. And of course, we can discover moons, binary objects, rings, and debris fields around the objects too, which is very important. And that's it. So let me stop my share here. Okay, any questions, guys?
Thank you,
Very
Chris.
good, Chris. Thanks.
Thank you very much. That was fantastic.
Yeah.
Yeah.
A
Yeah.
bit
Thank
of
you.
Lightness in the front and then straight science and astronomy and photometry.
Yeah.
And bam,
Yeah.
all the math.
It's amazing how much promotion has to happen in the background and all the things they go through to promote these missions to get them accepted. As some of the sausage making that none of us really can appreciate, I guess.
Nice to have an inside look. Get to attend one other Lucy talk with one of the main investigators, and Chris was one of two people who were not NASA employees that were listed as helping out amateurs doing the occultations. So he got his name associated with the Lucy project because of it.
Probably because I was her partner in her previous mission too. I think I was with her and we went to Mendoza, Italy, or Argentina. She was my partner there and we did an occultation expedition together. And so she reached out to me looking for pictures to share on that. I said, I'm just one of about 50 people that really like doing this. In fact, if any of you guys are interested in occultations, there is a group called IOTA, the International Organization of
International Occultation and Timing Association.
Oh, there it is. Yeah, I always get that wrong. Anyway, that if you belong to IOTA and learn how to do occultations happening. Their shadows of various asteroids are passing over the Earth all the time. And the cost of equipment to get involved in this isn't that horrific. You can do this with analog video cameras and external GPS timers. The easiest is the QHY camera. It makes everything so much easier to do. And you can make major contributions to real science by being part of IOTA and get your name in many scientific journals and publications as co-discoverers and co-contributors on many scientific papers. And so it's sort of a cool way to make an actual contribution as an amateur into real science.
Hear that, Kirsten, Jacob? Start planning, doing citizen science. Another 12 years, Lucy will still be active.
Yeah.
Wow, that was amazing, Chris and Maureen. Thank you so much. Anyone else have any further questions? And are you still gathering your head around some of that?
I have a question. How old is Jacob? Jacob, how old are you?
I am 12.
Ooh, you could be working on this mission. What grade are you in?
7th.
Oh, yep. They said 6th grade, and you could be out of college and
Yeah.
working on this mission before it ends. Very cool.
Yeah, well, there are some occultationists that are in the range of 10 to 15 years old that are out there. Typically, they're not allowed to travel out of the country right now, but if you get good at this age, that it's a real good chance that NASA would be happy to use you in doing future expeditions. And there are quite a few occultations that are taking place within the US too. I was just part of one that took place in Texas about a month and a half ago that they flew me to Texas to do that occultation. And there's another one in about a month and a half that's going to take place in Arizona. And so the ones that take place within the US that minors can travel to and be part of the expedition and get your name at 12 years old in the scientific journals, which I think is way cool.
Very cool.
And as soon as you're 18, then there's the chances to travel beyond the US into other countries to do these occultations. But joining IOTA and getting involved is the best way to start. Not to mention you get to rub elbows with all of the various scientists and engineers and technicians and so forth involved in these projects. In fact, Alan Stern, who was the principal investigator for the New Horizons mission, that he came with us to Argentina to do the occultation in Patagonia, Comodoro Rivadavia. And I'm the one that collimated his telescope for him since he didn't know how to do it.
Ooh.
In fact, I collimated all the telescopes for the entire expedition there because, of course, being the engineer and being a little bit of a hardware geek, I could collimate 50 telescopes faster than any one of them could collimate one telescope.
Yeah.
I just posted the link to IOTA in the chat if anybody wanted to see it. And
Oh, great. So if anybody's interested in IOTA, I'm always happy to answer any kind of questions and do what I can to get you going too. It's a lot of fun. You get to travel, you get to meet a lot of really cool people, and you're doing real science, and you will get your name into real journals.
And if you missed some of the links from the chat, I think my recording saves the chat, so I can post them to the news group afterwards, today or tomorrow, when it finishes downloading. Otherwise, sometimes what I just do is click the link, it opens a web page, and I leave it there and go back to the meeting. So I just save them later.
It is good
And
to
I
check these things because sometimes they actually occur where you live, and that was our experience out here on the Big Island of Hawaii. So sometimes they're near you, and trust me, it is wonderful fun.
It's true. Sometimes they are in Connecticut and nearby. I've seen notices fly by in occasional the newsletters for IOTA. I'm a member, but have never participated because when I joined, it was all when you build your own equipment for the timings, and none of the equipment was available. And now they changed it to a more standardized system, and I haven't kept up.
Yeah, QHY camera and the program SharpCap work just great. In SharpCap, you can get a free version. The pro version is like 20 or 30 bucks. But both versions work great for occultations. And so the only serious investment you're really making besides your telescope is that QHY camera, which I think is like $1,000 to $1,200 somewhere in there.
Do you have it at your fingertips, Chris?
I do have one sitting around here somewhere. Hold on, I'll get it handed up to the camera here.
While he's doing that, I put a link to the resources for the Lucy mission in chat, and I will also send them to John in case you want to share them, John.
Thank you. Appreciate that.
Thank you.
Okay, now this is the camera right here.
All right,
This is that's a
put you
Hyperstar adapter for a C14.
see if I can get you full screen. If you change everybody to your speaker view from the view button, you can see the whole thing at once, just Chris.
Yeah, so this is the camera. This is a little dehumidifier, a little desiccant pack. Here's the GPS antenna. And it looks like a regular little CMOS camera, and it is. The difference is having that built-in GPS module that allows it to put very precise timestamps and latitude, longitude, and altitude on each FITS frame that it saves to your laptop. This is a USB 3 connection. So it's a power connection that does have a cooler built in, so it can cool the chip way down to increase the quantum efficiency. And this can go on to an SCT, which is what I got here with the Hyperstar, or you can put this on a Newtonian or regular Schmidt-Cassegrain, max it up, where do you have, and do some great occultation work with this camera. It's a lot of fun. Also with IOTA, there's a bunch of free software. One's called Occult Watcher, which will actually watch a bunch of asteroids and so forth. Will actually tell you which occultations are going to be happening either near you or right over top of you. A lot of people do occultations within a 100-mile radius of their homes, is all how farther they go. And they manage to contribute an awful lot of occultations because these shadows are passing over us all the time. And so some objects have a lot of occultations, some don't have any yet. So if you're interested in getting involved, you actually would be able to collect a lot of occultations without even doing much travel.
Excellent. Thank you. Does anybody have any more questions for either Chris or Maureen?
And I
If
see
not-
Carson. It looks like Carson's at the right age too. Carson, how old are you?
I'm 12 and a half.
Oh, perfect. Great. So we got two
We've got a-
candidates here.
Yes, the science team starting at the right place. It's junior members of
Yeah.
ASGH.
Yeah, wish I had started at 12.
Well, Chris, Maureen, I really want to thank you for taking your afternoon in Hawaii time or California, for spending an evening with us out in Connecticut and sharing such a very important mission that's literally going to launch a month from now. So we'll be keeping our eyes open for it. And thank you very much and for joining us, and a round of applause from everybody, or a thumbs up
Yeah.
or something if your camera's not on.